In this podcast, we're going to talk about how to name ionic compounds, also known as ionic nomenclature. All right, so don't be overwhelmed by this. This is the rules to name all ionic compounds. What I want you to focus on first is how to name binary compounds, which means there's no polyatomic. So you're just going to write the name of the first element, and then you're going to write the name of the second element, and you're going to change your ending to IDE. So here are some examples of binary compounds. So we're going to practice how to name them. All right, so you write the name of the first element. So Na is sodium. All right, and then you write the name of the second element, which is bromine, and change the ending to IDE. So instead of bromine, I'm going to have bromide, sodium bromide. All right, next example is Al2S3. So write the name of the first element, which is aluminum. All right, and then we're going to write the name of the second element, which is sulfur, but we're going to change the ending to IDE. So instead of sulfur, it'll be sulfide. So aluminum sulfide. All right, and lastly, we have what's the name for CaO. So write the name of the first element, which is calcium. And then write the name of the second element and change the ending to IDE. So oxygen turns into oxide. Okay? All right, now I want you to focus on how to name ternary. Ternary means there's a polyatomic. So when you look at it, if it's got 3 or more capital letters in it, that means it's got a polyatomic in it. In these, you're going to write the name of the first element, and you're going to write the name of your polyatomic. So for example, here you see we have a ternary because it's definitely got more than 3 capital letters. So we write the name of the first element, so Li is lithium. And then you need to look at your polyatomic ion sheet and figure out what this guy's name is. So if you look, C2H3O2 is acetate. So you just write acetate. So the name of that is lithium acetate. All right, next one, MgSO4. So you write the name of the first thing, which is your metal. So Mg is magnesium. And then you've got SO4, which is the polyatomic sulfate. So magnesium sulfate. All right, and the last example, K2Cr2O7. Okay, so you definitely have to make sure that you can identify what part of it is the polyatomic. So we've got K, which is potassium. And then we've got Cr2O7. Cr2O7 is our polyatomic in this case. So Cr2O7 is called dichromate. All right, next we're going to focus on a few additional things that you need to be aware of whenever you're naming binary or ternary molecules. One of them is you need to check your first element and see if it's multivalent, meaning is it located in the middle or the skip column? If it is, you're going to use your normal binary and ternary rules like we have done above, and then you're going to use a Roman numeral after that first element to indicate the charge of that multivalent ion. Remember, there are 3 exceptions for us for the middle that will never require a Roman numeral. So never put a Roman numeral with these 3, but we're going to have to for the rest of them. So to put your Roman numeral, you have to determine the original charge on your metal. So you kind of have to do like reverse swap and drop. Okay, so here we've got a 2, right, on the end. So the 2 had to come from Sn, and the 3 had to come from N. So our Sn's charge would have been 2 plus. Okay, down here you see that there is nothing there, right? So you should have immediately probably thought, oh, that must be a 1 plus charge. Well, this one is kind of deceptive because P is in the 3 minus column. So the only reason why there wouldn't be a 3 down here next to SN is because SN was a 3 plus and they canceled. So the charge on SN was 3 plus. Down here, SnCl4, hopefully you saw that 4, realized it come from SN, and then SN got a 1, that came from your Cl, right? So your SN has a 4 plus charge here. This is one way you can look at it. Another way you can look at it is by doing what I call the I bar. So I'm going to do all 3 of these examples again, but with the I bar. So in an I bar, you put all of your positives on one side and your negatives on the other. So we had SN, and I need to put the exact number of them. Well, I have 3 of them, so I'm going to write SN 3 times. All right, and then I have N, and I have 2 of those because of that little 2. Now, I always will know the charge on my non-metals on this side, on the right side. So I know that N is in the 3 minus column. So that means that total, that whole side, is 6 minus. Now, because there is no little top subscript up here for a charge for the whole thing, we know that the metals, the other side, had to be 6 plus, so everything cancels and the molecule or compound is neutral. If this side is 6 plus and I have 1, 2, 3 SNs, that means each of them had to be 2 plus a piece. Okay? So you see we got the same answer as we did the first time. Okay, doing the I bar on the second question, we had 1 SN and 1 P. There's no subscripts here. Again, we know the charge on our nonmetal is 3 minus, so this total for this side is 3 minus. So this side is 3 plus, there's only 1 SN, so he had to be my 3 plus. So again, same answer. And then the last one, I have 1 SN, 4 CLs. They're all 1 minus a piece, right? So that means total for this side, I am 4 minus. So this side has to be 4 plus. There's only 1 of them, so it's got to be all that guy. Okay? All right, now once you determine the charge on the metal, you are able to write the name. So here we have Fe. This is binary, so we're just going to do like we usually would in binary. So we got iron, and then I'm going to need my charge, my Roman numerals. So I see that there's a 3 here. So that means my Fe was 3. So I'm going to do Roman numeral 3. And then oxygen, change the ending to IDE, so oxide. So iron 3, oxide. All right, next example, CuSO4. Cu is copper. Copper is in the middle, so he's definitely going to need a Roman numeral. And we need to figure out his charge. Okay, well, most of you are probably looking at that 4 and thinking, oh, well, copper's charge must be 4. That is not correct. That is inaccurate because this has 1, 2, 3 capital letters. That means there's a polyatomic in there. The polyatomic is SO4. So if I write me a little small I bar here, we got 1 SO4 that has a charge of 2 minus. So that means my copper was 2 plus. So copper, Roman numeral 2. SO4 is sulfate. So copper 2 sulfate. Last but not least, ZnCl2. Zn is zinc. Even though it's located in the middle, it's one of the exceptions that never needs a Roman numeral, so I don't have to worry about that. So zinc, and then change the ending on the second element to IDE, so zinc chloride. All right, our last set of rules that we're going to look at is to see if our formula contains a positive polyatomic. Remember, I only gave you 3 that you had to know about. You should have marked them on your polyatomic sheet. So to name something with a positive polyatomic, you're going to write the name of the positive polyatomic. And then if it ends in just a single element, you're going to just change the ending of that element to IDE. But if it ends in a polyatomic, you're going to write the name of the polyatomic. So for example, we have NH4. NH4 is ammonium, so I'm going to write ammonium. All right, and it ends in a polyatomic, CO3. So I'm going to write the name of that polyatomic, which is carbonate. So ammonium carbonate. All right, again, second one, I have NH4, so that's going to be ammonium. This time, though, we end in just a single element. So instead of sulfur, we're going to change the ending to sulfide. So ammonium sulfide. All right, this last one is a little bit different because you don't see any parentheses, right? So it's kind of harder to tell that you have a positive polyatomic. But you do. It's H3O. H3O is hydronium. And then it ends in just a single element. So you're going to change the ending to IDE. So chloride.